So some of you have said that you were having a little bit of trouble with this lab, so I thought that I would walk you through some different parts of it just to make sure that you understand. So looking on this first page, all it's asking you to do is to draw a diagram. So it says study the pattern. So if we were doing 2 rows, it says 2 rows of 3. So that's the description. So if you notice, I drew 2 rows of 3 boxes. So then it says, what is the process in order to find the number of tiles? So if it was 1 row of 3, we said that we would do 1 times 3, and the answer would be 3. So then for this row, if it were 2 rows of 3, that means I would do 2 times 3, and that means that the total number of tiles would be 6. So when you get down here to the bottom, and it actually says that they want you to develop a generic pattern, and they say X, you obviously can't draw X number of rows. So this would be how many rows of 3? Well, it would be X number of rows. So if this was 10, then it would be 10 rows of 3. If it were 12, it'd be 12 rows of 3. If X was 100, it would be 100 rows of 3. So we would say X rows of 3. And then you're going to follow the pattern here, and we would say X times our 3, and we would get an equation. So down at the bottom, it says, how is the rate of change demonstrated in the diagram? So you want to tell me what changes in each diagram that would represent slope, or the rate of change. Then, graph the number of square tiles as a function of the number of rows on the provided coordinate plane. And I think they already did that for you on the next page, but maybe not. But obviously we didn't provide you with a coordinate plane, so you don't need to graph. Okay, then it says, how is the change described in the verbal description? So again, we're just asking what changes each time that you write this that represents the rate of change. And then the same thing in the process, and then the same thing in our generalized equation. So where did you find slope in the generalized equation? And then it says, how is that rate of change demonstrated in the graph? We don't have a graph, so obviously you don't have to do that part, so you can cross it off the bottom. Okay, so it says graph on the provided coordinate plane. There's not provided one, and so then we obviously can't talk about it on the graph. All right, so flip to the next page. I think I'm actually going to take the staple out so that I can fold and do what I need to do. So on the next page, it talks about how to define slope. It says, in the previous activity, you investigated the steepness of lines and connected that the measure to the equation, the graph, and the change in the y values all has to do with steepness. So the measure of steepness of a line is called, well, that's what the entire lab is about. That's going to be slope. And then it says, in a linear function, the slope represents a comparison of, and it's what we talked about on the first page, the rate of change in the variables. So you've got slope and rate of change. So it's the ratio of the change in the vertical distance to the change in horizontal distance, which we said we could rewrite. The vertical distance on a graph is y. So we said delta y over the change in horizontal distance, which is delta x. So then they give you an example here in the graph, and so then they ask you, in looking at the graph, they want you to find the slope, and then they actually provide you with an example of how to find the slope. So it says, what's the vertical change? So again, if we were to count 1, 2, 3, 4, and we went up, so it's positive 4. And then my horizontal change, 1, 2, 3, 4. So my horizontal change is 4. And then we went to the right, so it's positive. So we'd say 4 over 4. Well, if I actually divide that in my calculator, it comes out as 1. So the way that we could describe that is we would say the top number, so if we have a slope, we said it's always y over x. So if we were to describe this, this one would be 1 over 1. So as x increases by 1, y increases by 1. If we were to change it to say -2 over 1, now I would say as x, because again the x is on the bottom, increases by 1, y decreases, because it's negative, by 2. So when you're trying to read the slope, that's what you're going to be looking at. So if we even changed it more, if I say 3 over 2, then I would say as x increases by 2, y increases by 3. So that's what they're asking you for down here. So it says if the y value of a linear equation increases by 4.5 when the x value increases by 1, what is the measure of the steepness, or what is the slope or what is the rate of change? Those all mean the same thing. So that's where we're comparing what is our change in y versus our change in x. And so you would fill those numbers in, divide it out, and then get me an answer. So going back up, this says if we choose another 2 points on the graph that's above us, and the ratio of vertical change to horizontal change was calculated, would it still equal 1? Verify your answer. So if you're looking at the graph that they provided us with, what we want you to do is pick out 2 different points, and it doesn't matter where they are. So you could pick this one and this one, or you could pick one up here and one down here, as long as it's where on a direct corner. You don't want to pick one that's in the middle of a square, because then you have to try to count a half. So pick 2 new points, put them on your graph, and then actually write your points. So x comma y. Nah, you don't have to write your points. Just put them on your graph and then count them so that you can show me where you got your number. Okay? Good. So moving on to the next page. So now it says that slope is represented by the variable m. And the way that you can remember that is for a graph, m stands for the movement. So that's how we're going to move. So in the equation, which you usually write as y equals mx plus b, the slope is always the number in front of x. So slope is always with the x. So for example 1, it says, well, how do you find the slope then? By looking at the equation of a line such as y equals 3.2x. Well, we just said the slope is always the number that's with the x. So the slope itself is literally just 3.2. So we would say m equals 3.2. Then it says the slope is one of the parameter changes that affects the linear parent function, meaning that it always starts at 0 and increases up 1 over 1, unless we start to change the slope. So positive and negative, those are on your notes for 4.1, so you can describe the graph of what happens. But these are the two that I'm not sure that you understand. So when the slope of m is greater than 1, so for instance, let's say we had y equals 4x, or y equals negative 5x. Notice my slope is 4 and my slope is negative 1. Okay? When that happens, that means that the graph is going to be steeper. Or you can put that it's more vertical than the original graph. So let's say, and I'll put it over here, so I'm going to show you m is greater than 1. If this is our axes, here's our original parent function that goes right through here. This is our parent function, y equals x. If I were to graph y equals 4x, that means that it's going to be steeper, but it's still going to go through 0. So this would be y equals 4x. So the bigger this number is, positive or negative, the steeper the graph is going to get. So then it says, what if the slope is between 0 and 1? Well, what are the only types of numbers that are between 0 and 1? Yeah, 0.5, 0.75, 0.666666, right? These are all fractions. So if we have y equals now 3/4 x, or say y equals 1/2 x, now instead of the graph being steeper, the graph is flatter or more horizontal than the original. Now remember, not all fractions are between 0 and 1. If you have an improper fraction, like y equals 5/4, that is not going to cause the graph to be flatter. It's bigger than 1, so it's actually going to be steeper. So be real careful. Just because it's a fraction doesn't mean that it's going to be flatter. It has to be between 0 and 1. So if we were to take this same situation and look for 0 less than m, which is less than 1. Here's our original again, so here's y equals x. But if I were to look at y equals 1/2 x, now it would be much flatter. So here would be y equals 1/2 x. Good. And then the last part says, when the slope m is changed, does that change the y-intercept? Well, remember, the y-intercept is where the graph crosses the y-axis. So if you look at the graphs that I just drew, here's y equals x, here is y equals 4x. I did change the slope, but they still both go through 0. Here's y equals x, here's y equals 1/2 x. They both still go through 0. So does changing the slope change the y-intercept? No. So we'll say the y-intercept stays the same. Changing the slope does not change the y-intercept. So it says the slope of the graph of the the slope of the graph of the parent function is y equals x. And it's asking you what is the slope, and then what does that mean? So you should be able to answer those based upon what we've already talked about. And then down here at the bottom, finding slope from a graph. This is just a reminder, we've talked about all this, vertical versus horizontal, right, left, up, down, positive, negative, that kind of stuff. So moving on. Now they want you to go into actually using the formula. So if they don't give you a graph, we said we were going to use the formula. Well, this isn't any different than what we were doing earlier. This is y2 minus y1 over x2 minus x1. The only difference is that now they're putting it into a big separate thing. So they're wanting you to find the change in the x's first, then find the change in y's, and then put it all together. So where did they get the 2 and the 1? Well, they got it in the x column. So we said 2 minus 1 was 1. Then for the change in y, we went straight over to the y column and we picked 8 and the 1 above it, which is 4. 8 minus 4 was 4. Well, then once I had the change in y, which was 1, and the change in x, which was 1, and the change in y, which was 4, I said delta y, 4, divided by 1 was 4. So now if I were to do the same thing here, I want the change in x, so I'm going to go to the x column. I would slide straight across and I would use 4 and 2. So 4 minus 2 is 2. And then here's the change in y, so I'm going to go to the y column and I would do 16 minus 8, which is 8. So now I do delta y, which is this column, so 8 divided by 2, which is 4. And then they did the next one for you and they got 4. So you should figure out that your slope should be the same no matter which 2 points you choose. And then we've already talked about what it means as x increases by 1, and so you can fill this out. And example 5 is the exact same thing. So you're still just using the formula. Good. So let's look at page 5. It says, what is the slope of a horizontal or a vertical line? You should already know the answer to that. We said horizontal should be 0. Vertical should be undefined. Those are 2 things you need to memorize and get into your head. It says, go ahead and plot the points on the graphs provided, draw a smooth line through the points, and then complete the table to find the slopes of those special cases. So we already know the answers, but now they're asking us to prove it. So the first thing that we need to do is graph. So I'll help you with one of them just in case some of you have forgotten how to graph. So the first point that they want me to graph is -2, 2. Remember, this is the x and this is the y. So I need to go to -2 on x, so that's here, and then 2 on y. So 1, 2, -2 on x, 1, 2, so there's 2 on y. The next point is 0, 2, so I need to go to 0 on x, so here's 0, and then I would need to go to 2 on y, which is here. 4, 2, so I would go to 4 on x, and then 2 on y. And then 7, 2, so I would go to 7 on the x-axis, and then 2 on y. So there's my 4 points. Now it says draw a smooth line. So there's my smooth line. And now it says then find your slope. So notice it's delta y over delta x, so they're still just asking you to use your formula. So y2 minus y1 over x2 minus x1. So for this line, remember I would go straight across and I would do 0 minus -2. So if I were setting this one up, and I'm just going to kind of put a star and then put it over here, 0 minus -2. And then I know there's going to be a minus here as well. Sorry, I'm not paying attention. Try this again. Sorry, the x's go on the bottom. So 0 and your -2 go on the bottom because these are your x's. And then in the y column, 2 minus 2. So then you could figure this out. 2 minus 2 is 0. 0 minus -2 is 2. 0 divided by 2 is 0. So in this box you could put 0 over 2 equals